Now, okay. Now, let us try to understand all of you. See, this is surface, and on this I kept object and I applied force, and this particular object is sliding it. Sliding means moving entirely. This object is moving entirely. Suppose, for example, you take one table, a big table, and you drag it with your hand. Then what happens?
Sir, can you repeat your question?
One table is there, big there, and I applied force on that to make it to move. What happens then?
Sir, it slides.
It will slide. It will move on that surface totally. So that means it will slide. And whenever an object is sliding on the surface, then whatever the frictional force will be there, that will be called which friction? Sliding
Sliding.
friction. Okay. Now, in order to make it to move very easily, now what I did is I took same block and I kept two wheels for it. Now if I apply force, whether this block will move easily or it will not move easily. Have you understood my question, all of you?
Sir, it will move easily.
Kavya,
It will move much more easily.
Kavya, repeat my question.
If you put these round spherical objects under the object, will it move more easily?
Uh, whether it moves easily or not. Naisha,
Yes, sir.
it moves easily or not?
Well, sir.
Arya,
Sir, moving.
easily it will move. Why it will move easily? Arya or Naisha?
Sir, because the work is being distributed. Initially, it's just the table, but then now it's table and the spherical object.
Tell me, Akshat. Akshat, can you hear me, Akshat?
Sir, can you hear me now?
Now it is clear.
Sir,
Tell me.
I have one single doubt. Does friction act in air? Like when you are in an airplane or something, does a friction act on it?
Friction will act even by air also. That will be called air friction, but you are going to learn about it while you learn about fluid friction. Generally, fluid friction means the friction which was um, acted by either liquid or gas. So that will be called fluid friction. And whenever you learn about it, there you will learn, Nana. But now you have to understand about these concepts. Okay.
Okay, sir.
Right.
Understood.
Akshat, tell me now when we are keeping this what? What we kept, Nana, for that particular object.
Sir, I didn't get your question.
Suppose I took one object like this, and for object I kept two wheels down.
Okay.
Whether object will move easily or it will not move easily.
Sir, it will move easily, sir.
Why it will move easily?
Sir, because when you exert force in a certain direction, friction opposes it. So the wheel is in such a uh, uh, position where if friction is acting, the wheel will spin around. Something
Okay.
like that.
Sir, may I?
Okay. Except Ronak, any other members try, Nana? Naisha.
Yeah, sir, I answered earlier saying that since, like, you
Already
see in
you
the first
answered.
picture, uh, all the force that's being applied to move it is being applied on the blob. But in the second thing, wherein we use wheels or something, the work is being distributed, which makes it easier to move.
Okay. Alex. Alex, can you hear me? Alex, can you hear me or not? Alex, can you able to answer it? Why it is easy to move when wheels are kept for that object?
Sir, may I?
1 minute. Ronak, tell me.
Yes, sir. Sir, because the friction exerted by the wheels are very less than the sliding friction.
Why very less here? Why very less in this case?
Sir, because the surface contact is very less.
Very good. The area of contact is very less. Just now I said the frictional force will depend upon area of contact here. And here area of contact is more, and here area of contact is, area of contact is very less when we kept wheels for this. So that's why the frictional force is reduced further. And according to this, tell me whether sliding friction is more or rolling friction is more.
So sliding friction.
Sliding friction is more. Rolling friction is
Less.
less. Now, generally, what is rolling friction? When a body rolls or rotates on the surface of another body, then whatever the friction is developed between that object and surface will be called rolling friction. And as usual, the rolling frictional force Fr, you can write it as what? Mu r into n here. Sorry, mu r into n here. And mu r is called what? Coefficient of rolling friction. N is called what? Normal reaction. Fr is called what? Rolling frictional force. So is it clear? Three equations. Fr is equal to mu r into n. Fs is equal to mu s into n. Fk is equal to mu k into n. Is it clear all? All these three equations?
Yes, sir.
Others. Others also have to respond. Respond.
Yes, sir.
Okay. Now, in this way, how many types of friction will be there?
3.
Three types of friction will be there. What those three types are?
Static friction, kinetic or dynamic friction, and rolling friction.
Okay. So, static friction, instead of kinetic, you have to say sliding. Sliding friction, and next rolling friction. And sliding and rolling comes under kinetic friction. And in which of the cases object is in a state of motion, either for a sliding or for a rolling. But for which condition the object will be in a state of rest? For a static
Static.
friction. Okay, good. So this is about static and kinetic, and in kinetic sliding and rolling. Now tell me in order which frictional force will be more among all these three.
Static friction.
Very good. After starting friction, which is more?
Sliding friction.
Huh?
Sliding.
Very good. First starting friction is more, and it is more than the sliding friction. And sliding friction, I'll write it as kinetic friction. Sorry, this is F no. And next it is greater than which one? Rolling friction. So you can write like this. rolling friction is less than kinetic friction is less than static friction. Is it right?
Yes, sir.
Akshat, is it right or wrong?
Yes, sir. Even I agree with it.
You will agree with it.
Yes, sir.
Okay. So these two orders you have to remember and they may come in your examination. Which frictional force is more? Then what do you have to say? Akshat,
Yes, sir.
which frictional force is more?
So, rolling friction.
Rolling friction is more or less?
It is more.
Again, Akshat, I wrote their relation also. Fr is less than Fk. Less than means small or more?
Um, Sorry, sir. I jumbled it. It's
Uh,
actually static friction. Rolling friction is the least.
Rolling friction is least. Which is the highest?
Static friction.
Very good. Rolling friction is least. Static friction is more. In between these two, which friction will be there?
Sliding
Um,
friction.
Sliding friction will be there. Good. So you have to remember this order.
okay, sir.
Again, I am asking for Naisha. Tell me, Naisha, order of frictional forces.
Sir, rolling friction is least, sliding friction after that, and static friction is.
Okay, if I give any question like this, will you answer correctly in examination?
Sir,
If I give this type of question, will you write correctly or not?
Yes, sir.
Okay, right.
Excuse me,
So, tell me,
sir. I have a question.
tell me.
Sir, in static friction and sliding friction, sir, if we take only one object, the surface contact or area contact is same. So, how can sliding friction be less than static friction?
Okay, right. Very good question you asked. See here. Now, I'm drawing here. Suppose object is there like this, and it is in a state of rest. When it is in a state of rest, what happens is now this object and this surface both will have some unevenness or not. Like this, some hills will be there or not.
Yes, sir.
And these hills of surface and this object when they are at a rest will interlock with each other. And when they are interlocking with each other, what happens? You have to apply more force. That means more opposite force will be applied. So more opposite force means more frictional force here. And suppose when an object is moving on this particular same surface, moving on it, and moving on it means it is overcoming this particular interlocking or not.
Yes, sir.
Now this much of interlocking will not be there when it is moving on this particular surface. So as interlocking is less than that of this state of rest, that's why here the frictional force will be what? Less than which one? When object is there in a state of rest. Is it clear?
Yes, sir.
Others, is it clear?
Yes, sir.
Okay. Now in this way, how many types of friction are there? Right. Okay. Now let us move to next slide and we'll learn about other things. Friction is due to the deformation at the point of contact and depends upon area of contact. Now let us learn about laws of friction. That means friction will depend upon what? So first point, see here. Friction depends upon the nature of the two surfaces in contact, whether it is true or wrong. Ronak, whether it is true or wrong.
So, can you repeat the question?
friction depends upon the nature of the two surfaces in contact. Is it right or wrong?
That is right.
Right. If smoothness is there, then frictional force will be less. If rough surface is there, it will be more, and it will depend upon the temperature of the two surfaces also. Why it is temperature? Because when temperature increases, that smoothness or roughness also will change. So that's why it will depend upon the temperature also. So see there, friction depends upon the nature of two surfaces in contact. That means nature of material, surface finish, temperature of the two surfaces, etc. So this is the first point on which friction will depend. Next, coefficient of static friction depends upon the nature of the two surfaces in contact, and it is independent of the area of contact. Is it true or wrong? Ronak, coefficient of
Yes,
static
sir, it is correct.
depends upon the nature of the two surfaces in contact, but it is independent of area of contact. But for kinetic friction, what we said, when area of contact is less, the frictional force will be less. But for coefficient of static friction, what we are saying, it is independent of area of contact. That means static friction will not depend upon area of the contact. Kinetic friction only will depend upon what? Area of contact. If area of contact is less in kinetic friction, then definitely that coefficient of kinetic friction also will be less. Okay. Kavya, is it clear? Whether static friction will depend upon the area of contact?
It's clear.
Kavya, suppose one surface is there like this, and on that I kept object like this first, and I want to lift it. And when you are lifting it, some force you have to apply. And same object I took, but now I kept like this in reverse mode like this. And when I want to lift it again, whether I have to apply same force or different force?
I think the same force.
Very good, same
No,
force.
no, no, not the same force because the area of contact is lesser. Therefore, the force needed to lift it will be lesser.
So you are confusing here. For that only I asked a question here. Now static friction will not depend upon area of the contact. If contact area is more or less, when it is in a state of rest, to lift it, you have to apply same force. Okay,
Oh,
Kavya.
okay. Okay, sir. I got
Right,
it.
right. Now static friction is independent of area of contact between two surfaces. That only I explained. But kinetic friction is dependent on area of contact. But kinetic friction is independent of velocity of the body. That means if you increase the velocity or if you decrease the velocity, when it is moving on the surface, that particular frictional force will be remaining same. Maybe you observed that graph. In that graph, what you observed? See here, in this graph, you observed that a flat line is there. Have you observed flat line here? Flat line is there or not here? Ronak.
Yes, sir.
So this flat line will tell us even you increase the velocity, kinetic friction will remain same. So kinetic friction will be independent of what? Velocity of the body. And rolling friction depends upon what? Area of contact of the surfaces. If area of contact is less, rolling frictional force will be less. Isn't it?
Yes, sir.
Okay. Now tell me, generally heavy load vehicles will come. For heavy load vehicles, how many tires will be there? Have you seen sometimes a heavy load, this truck will have 60 tires. Have you seen?
Yes.
Others, have you observed the truck is having more tires?
Yes, sir.
Why? Why, Kavya, more tires will be there?
Because if there is more tires, then it can carry more amount of weight more easily, and the friction force will be reduced.
Ronak, can you tell me?
Yes, sir. Sir, because tires are rolled, so the friction will be less, and as there are many tires, so the friction will be less. So the carrying heavy load will be easy on roads.
Naisha? Naisha? Kirtana? Kirtana? Others have to speak. If you don't know answer, at least you have to say. Okay. Right. So, why? Because when heavy load is kept, weight will be more or not? Ronak.
Yes, sir.
When weight is more, then suppose only two tires are there, friction will be very less, no?
Yes, sir.
When friction is very less, heavy load is there, it can't hold it properly. So that's why to increase that particular friction down, what we do, more tires we keep. And when more tires are kept, more area of contact will be there at that time. And when more area of contact is there, frictional force slowly develops in such a way that it can bear that weight. Okay.
Yes, sir.
Okay. Now in this way, for static friction and kinetic friction and rolling friction, some laws are there and you have to remember them, and based on them few questions will be asked.